All right, here we go.
Here we
Okay.
go.
I can start with number 3. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of Z 1.358 and to the left of Z 1.358, negative 1.358. Round your answer to 3 decimal places. So
I got 0.175.
1.75.
yeah, that's what I have too.
0.174. Right. I
I
know
know round up.
my applet always does weird things compared to what the other guys does, like one off. But if it's 0.1745, it'd be 0.175. You would round up.
Yeah. Yeah.
Round up.
Okay, I'm with you. I'm with you.
Okay.
Okay.
Whoever wants to read forward.
I'll do number 4.
Okay.
Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? And I would say the distribution of the sample means, which is
I agree with that.
B.
Yep. Yep.
Because it's the small number.
Yeah.
If it was a-
I'll do number 5.
Divided by the square root of whatever. So yeah, that would be right. Okay.
Following results implies that the spread in the means decreases and the sample size increases. That's the sample mean, right? And then
Isn't that the central limit theorem?
No, I think it's law of large numbers.
Yeah.
I put number
Oh, yeah,
I put
you're right.
the
Oh,
last
I have such a hard time with those.
Okay, so central limit theorem is as the sample size increases and becomes large, the distribution of sample means becomes approximately normal.
That's right.
And then the law of large numbers is the greater amount of observations in our sample means draws closer to the population mean.
Yeah.
So I know these two are hard for me.
Okay. So law of large numbers, D, right?
Yeah.
Yeah.
Okay.
Okay, I'll do the next one. Can you tell me if you can see me? Because I'm going to click over on my tab. Can you still see me?
Yep.
Yeah.
Yep.
So number 7, what is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? Round your answer.
6.
Oh,
Right.
Or what?
6. Okay.
Diane earned a score of 1.
Earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diane's score? So you take 160 minus
The 150.
the new, and then and then you divide that by the standard deviation, and I got 0.174. If I have my answers written down in the right order here. Is that what you guys got?
That's not what I got. Give me 1 second. I want to check my math.
But-
You said 160 minus 150.8, and then you divided that by 8.8.
Yeah, but I can do it again.
Okay, I got 1.04545545.
That's what I got too, Frank.
Well, I might be on the other problem. I might have written down the answer for the next.
Yeah, that's what I got too. So 1.045.
Yeah.
Is that what you got too,
I'll do.
Jim?
Yeah. So yeah, do the math on that one again.
Let me do it really quick. Sorry, I might have skipped that when I was.
You're totally good. You had the setup right and everything, so.
Yeah, I know how to do it.
Mhm.
Here we go. I'll do it really quick. 160.
Okay.
Minus 150.8. 1.2 divided by 8.8. Yeah, I got 1.045. Right? Is that what you got?
Yeah.
Yep.
Okay. Okay, great.
I can go ahead and read number 7. It says, what is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? Wouldn't that be just the top half? Is that the top half of the z-score? Like you highlight it in blue.
Yeah.
Okay.
Yeah, so
And
it'd
then that would
be,
just be the area, so it's 0.148.
yeah.
Okay.
So the, oh, we don't put it in as a percentage though, right? We put it in like that 0.
What is it?
Wait, what?
Never mind. Sorry.
Okay, so this one, the 160 is the same as the previous problem, right? But now
Right.
we're
Yeah.
making it a probability. So do you put the you put in the area of that?
No,
Yeah,
you
but you
put
want
the
to
Z
highlight the
score in that
blue.
1.045 into the z-score on the probability applet. And then you just select to the right of the right red line, right?
Yeah, that's what I
Yep.
did.
Okay.
I think that's right.
Wait a minute.
Yeah, and then that gives you the area of 1.40,
4.8.
right?
Yeah.
0.148, yeah.
Uh-huh.
That's not too bad.
We're cruising.
We are
Yep.
flying.
Halfway there.
Okay, 8.
Yeah.
Started doing this one. Okay.
Okay, we have to do math on this one.
So it's a random sample of 5 students. What's left
So
of
it's,
the, oh, who's,
it's those numbers added up divided by 5. Is that right?
Yep.
yeah, so you get the mean, right?
Yes.
Let me redo it.
Plus 149.
That's going to be a nice even number. It's 160 again.
Yeah.
That's what I got. 160 minus 150.8. But
It's the same.
then because it's a random sample of students, you have to take the square root of the 5 students. I was trying to figure that out.
You do actually, that's right.
Yeah.
Okay.
Yep.
And then
2.338. Is that what?
Hang on, let's see what I got.
I didn't get that. But oh wait,
1.2.
is that like your bottom number?
So we have to take the square root of 5, right?
Yep.
60 minus 150.
2.236.
I got 0.467 or 0.468 would be rounded up.
Hmm.
That's not what I got.
3.
Let me see. Do it right. Should be.
I got 2.337.
Whoa.
I did it really fast, so maybe I should have.
Okay, Tamara. So do the math. Tell everybody the math.
Okay, so we got the mean of the 5 numbers, and then you take 160 minus 150.8, and that gave me 9.2. Let me make sure I did that right. So
That's
1.
right.
Okay, and then I took the square root of 5, which was 2.236. And then I took the standard deviation, which was 8.8, and I divided that by 2.236, and I got 3.935, unless I just did that backwards. Let me see. Square root of 5 is, yeah. So then you take the standard deviation, which is 8.8, divided by 2.236, and that gives 2.935. Oh, then you have to divide the 9.2. Well, that's what I forgot to do. I think
Yeah, I got 2.337 doing it
Nine.
that way.
2.337.
I got what Frank got after I redid it.
Yeah, 2.337.
Okay, what did I do wrong?
Is it 337 or 338?
338.
338.
Yes.
Thank you. Thank you for helping me on that. I always forget to do that.
So you guys did, I'm sorry. So you took the standard deviation, which was the 8.8, right? Or no?
Yeah, you take the 8.8, but and you
Divided
divide
by the square root of
square-
5.
right.
Which is 2.2360, right?
Yes.
I got 3.9355.
Then you have to divide that by the 9.
So you're one step, you're one
Oh.
step behind. Then
One more step. That's what I did too. I did the same thing. So you take 9.2 divided by 3.935.
yeah.
Did anybody take the individual homework quiz yet?
No.
Yeah. I have. I always take it before the group quiz because I feel like the group quiz is way easier than the homework, but
I think it is too.
Yeah.
So it's 2.338, right?
yes.
Okay, I haven't done this one yet. What is the probability that 5 randomly students will have a mean score that is greater than the mean achieved by the students in the previous problem? Okay, wow.
So that means the right side of the box of the probability applet will be highlighted. The rest of it won't be. The center and the left-hand side, right?
Yep.
Okay.
Okay, so do we
So we
put in,
just type 2.338 into the z-score,
Yeah.
and then like the right side, it's like 0.0097.
That's what.
2.33?
But then if you round it,
It
it
says
would
to
be
do to 4 decimal places.
0.010.
It says round your answer
What?
to 4
So it's
decimal
like
places.
Oh,
it's like a really, really
Yeah.
small number.
So it's 0.00.
97.
Yep.
That's what I got, 97. But if you only put 3 in, I don't know what it's told us to do. I'll have to look. Let's see.
It
says
says
4.
do 4.
4? Okay.
Yeah, do 4.
Okay, there.
Yeah, so that one was easier than I thought it was going to be. Let's see. Question 10. What is the shape of the sampling distribution if the random variable x, which represents the sample mean of the 81 students, are selected? I think that because of the size,
81. So it's got to be normal.
so it's gonna be normal. I'm going to say
Right?
normal.
Yeah.
Okay, so
Isn't it if it's above 30, it's normal?
Yeah.
Yeah. Because the higher the number gets, the more likely it's going to be normal.
Right.
Normally distributed, I should say.
Yeah.
yeah.
I'll read the next one. What is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population?
See, that's the kind of stuff that drives me crazy about these questions.
What?
Yeah.
You
Like,
do the square root of 81, right? Let me think this through. But we have, if this is taking information from the previous, okay, so we have 3.5 is the mu. And the
Oh,
standard
don't we use that other thing to do this?
No.
and a random sample 81. Oh, okay, hang on. So we have a mu of 3.5. Standard deviation is 0.7, and then a random sample of 81.
Gosh,
what the heck?
I don't know. All the words on this question don't even make sense to me right now.
What is the standard deviation of the distribution of sample means for all possible samples of size 81 that can be drawn from the parent population?
Oh, the mean of the sample mean is the mean, right?
Yeah, I think it's
So it's
Right.
So
Okay,
wouldn't
so
it just be
3.5.
3.5?
yeah.
Okay, so we're just overthinking it.
Why was that so hard?
What did you do?
So the mean of the distribution of sample means is the same as the mean.
Oh,
Yeah.
just 3.5.
Yeah.
Yeah.
Oh, you guys, come on.
Number 12 is really easy too.
Okay, that was tricky. That was a tricky question.
Yeah, I can read number 12. It says, what is the standard deviation of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population? I did 0.7.
Okay, and this is the one that we do. If the standard deviation of it's going to be less than, because it's the square root.
80, yeah, it's the standard deviation divided by the square root of 81, I believe, right?
Is it? That's lame. Probably is.
Do we know what the standard deviation is up here? Let's look.
Yeah.
Standard deviation of the distribution of the sample means.
So it's 0.7 divided by the square root of 81.
Which is 9.
Oh, that's right. So
Yeah.
it would be 0.7 divided by 9.
Wouldn't you have 0.7 divided by 81, or divided by the square root of 9?
Yeah.
Or of
Yeah.
9.
So
Yeah.
I got 0.7. Wait. That's not, doesn't look right. Yeah, you take 0.07.
Yeah.
You divide 81, which is 9, into that, right?
So 0.7 divided by 9, I think, is the answer, which is 0.078.
This is like the one that we talked about, Jim. That
007.
the answer is so similar to the question. Sometimes you can be like, wait.
Right. So is that right? Did I figure that right?
Yeah.
0.7 divided by 9, which is 0.7.
0.077. Yeah.
Okay.
There
Is that
You wouldn't
right?
have to put up. My only concern is my question is, do you have to put in the 3.5 at all, or no?
No,
Well, this
because
asks
it's a
what is the
standard
standard
deviation. You don't use the mean.
Oh, okay. Good to know.
Yeah.
Okay.
So what 13 says, what is the probability that the mean GPA for 81 randomly selected students will be less than 3.3? Okay, here we go. Let me write this down.
Yeah, so I think I'm about to get it.
So we're going to take 3.3 minus something, right?
3.5.
Yeah, 3.3 minus 3.5.
3.5
We just did.
over the 8.8. I mean, not 8.8. I got it. Oh, it's 0.7.
Yeah, what we just did.
Yeah.
It's going to be a small number.
It's gonna be tiny.
81.
Actually, I got a bigger number. I got 2.5 or negative 2.571.
The probability, so you put that in the applet, and then you find the area.
Gosh, yeah.
You got negative 0.28571. Is that what you said?
That was for the z-score. Ignore what I said.
Yeah.
And-
Okay.
7.
Oh,
Scroll up and get the right. Okay, so 0.7 divided by 9.
0.0051.
So I got 0.005 for the probability.
Same.
So you guys did 3.3 minus 3.5, which is negative 0.2. Right?
Yeah.
So
Divided
wait, did
by
you get
0.7.
0.2? Did you get 0.2 divided by 007? 0.007?
Yeah, 0.07777.
Oh, because okay, yeah, okay. That's why I did it. That's where I went wrong.
Divided by.
And then that'll give you the z-score, and then you have to plug it into the
So I
alphabet.
got 28.57 when I did that for the z-score. Did you get that too?
Mm-mm.
What did you get as your z-score?
When I divided
2.571.
When I divided 0.007 into 0.2, I got 28.57. Let me do that again, though.
Yeah, that's.
Yeah, 0.2 divided by 0.077.
Because it's not it's 0.07, not
77.
0.007.
Wait, it's not.
What?
I got 007. It's not.
No.
0.7 divided by 9 is, okay, wait a minute, 0.9. Oh, 0.07. Okay. That was something that was crazy.
So it's 0.0052 is what you guys got.
Point.
So
Yeah, but-
3 decimal places would be 0.005.
Yep.
If you
I
get
think I got
2.857
And then plug that into the,
applet. Okay, here we go. What happens? Two point eight.
I got 2.564. I don't know.
564. Okay, so did you try 0.2 divided by 0.0777777?
negative 0.2.
Yeah.
Yeah.
It shouldn't matter in the z-score, but yeah.
So
Yeah.
I got like 0.0021 and for the probability. Is that what you got?
I got 0.005.
Yeah.
Did everybody
Yeah,
get that?
that's what I got too. 0.005.
So
Yeah.
what do you have as the z-score right now?
2.857.
Oh, okay. We have
like
2.5.
2.564.
Okay.
Or
Point
2.571.
0.2 divided by 0.
0.0.
0.07, right?
Yeah.
7.8 or 777. Yeah.
I got my z-score was 2.857. That's not what you got?
No.
So do a few more decimal places. So do
Okay.
0.2, negative 0.2 divided by 0.0777. Do a
I
few.
didn't make it negative. That might be the problem.
It shouldn't matter, but yeah.
Okay, so 0.2 divided by 2.857, right?
0.2 divided by 0.077.
Okay.
7.
Yeah. I'm sorry.
777.
We're gonna do it.
0.07 equals negative 2.85. I'm still getting 2.85, but you're not getting that?
Mm-mm.
What?
I'm
So wait,
doing something.
0.2 divided by 0.07777.
Oh, divided by 0.07777. I was just doing from 7.
Try that real
I
quick.
got 2.5. I got 2.57. What do you guys get?
Yeah,
Yeah,
that's
that's it.
what we got.
So then you put that into the applet, right?
Yep, for the z-score.
Here we go. Sorry, I'm taking forever.
No, you're good.
2.5.
Yeah, that's 0.0051, but
So let's be careful. So on question 13, it says that it'll be less than 3.3.
Yeah.
And the next question is
Yeah,
more.
that it'll be. This is the probability of it being less
Yeah.
than 3.3.
Oh, it's the same, obviously.
And then
Okay.
greater on the 14.
So that last question we just did was question 13, right? 0.51.
0.005.
Yeah.
so then the next one would be the left hand, let's see, the right hand side and the middle, right?
Yeah.
Yep.
Yeah.
So
Yep. It'll be everything.
0.995.
Yep.
Yeah. 995.
Wait, so what did you just do to the applet? You just kept the same
Um,
columns,
so-
right?
Yeah, so greater than you'll highlight the farthest end of the applet and the middle and leave the farthest end blank.
So you got
So the middle
0.99.
and the right side are highlighted.
Yes.
Hey, if that's accurate, then would question 7 be different?
Why would 7?
What is the formula? The mean will be greater than 3.3.
No, because our answer was the negative. Remember?
Gotcha. I was
Look
just
at
trying
the
to
look at the z-score of 6. That is really high. Like having a z-score 1 or 2 is like pretty high. And
Well, on
this is
7,
the
our z-score answer was the positive number. And in this question, our z-score was a negative number, right?
7 was above, and this one is, let's see, 13 was less than 3.3. Wait a minute. So did we do it backwards?
I don't think so, guys.
I
I
think
don't
we've done them all correctly.
Okay, we'll just run with it.
Frank, does that make sense though, what I'm saying?
It kind of
Don't
does. I was
second
just
guess
curious if it mattered because it's saying above.
Right.
160.
So, but when we got our z-score for that 160 or whatever,
Yeah.
what would be greater than 3.3? Our z-score, the answer we got was negative. So that's why it's going to be above the negative line.
Guys, question 14 is if it's above 3.3, and question 13 is if it's less than 3.3. So did we do it backwards on 13? Like
No.
No.
No, I think we did it right because that's that left red line is the 3.3, right?
Yes.
Okay.
But on the other one, it was the right line.
Okay.
Okay, but I'm saying that, did you look at question 14 yet?
He's
Yeah.
actually talking
Yeah.
about question 7.
Yeah.
So,
Okay. Yeah, I think we did 7 right.
Okay, cool. Keep going then. Sorry about that.
No, that's good. But question 13 and 14 are the same thing. One's less and one's greater than 3.3. So my question is, question 13, should we have done the little area to the right of the z-score?
no, because
No.
3.3 is that left line.
Yeah.
So
What's
less than
14?
that would be to the left side.
It'd be the middle and the right.
And greater than
know.
that line would be the middle and the right side.
Yeah.
Yeah.
I know, but it asks for less than. You know what I'm saying?
Right. And we did that already.
Yeah,
on
less
13.
than
It's the 0.005.
So how we got that is we just shaded the left side on the applet, just the left. Does that make sense? And then on number 14, we shaded the middle as well as the right side.
Because it's everything above
Oh,
that
okay.
line
So
on
on
the left.
13, did you get 0.0051?
Yep.
Yeah.
Okay,
0.005 with the
Just 0.005 because it only asks for 3 decimal
And then
places.
on 14, you just do the opposite, right?
Yeah.
No, you
Well,
do
the
the middle and the right side.
Middle and the right. Okay, yeah, that's what I was saying. Okay, that's exactly what I was saying. Okay. I can't see you guys because I can't get you on my screen at the same time I'm doing the problem. So.
No problem.
I think Frank's getting a headache.
No, I'm just tired. I played basketball a little bit earlier today. I'm just tired.
Because if you're not getting a headache, I am.
Are you?
All right, last question, guys. We can do it.
Yeah.
I'll
I'm
read it.
curious to see what you guys got because I feel
The
like
United
my
States Coast
numbers
Guard
like
assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but we raised after a tragic boating accident. The standard deviation of passenger weight is 26.7 pounds. The weight of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample.
yeah, I'm really curious to see what you guys got because my number is like way out there.
Okay, so as extreme or more extreme means that we are not only interested in values that are lower than ones we observe, but also values that are as far away from the mean as ours in the positive direction. Okay, so Mean weight is 185. The previous value was lower, but was raised after the boating accident. The standard deviation is 26.7. The weights of random sample of 48 commercial boat passengers are recorded. So we have to get the square root of 48, right?
Mm-hmm.
Yes.
Square root of 48 is, so that's divided into the standard deviation, which is 26.7. So I got the standard deviation on the bottom is 3.853. And then we're going to take the top.
Oh, okay. Never mind. That.
So I got a z-score of negative 1.920. Did you guys get that?
Yep.
So we take that. So now we have our z-score. Woohoo!
Yep.
Let's
And it says find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in the sample.
So wouldn't it be on two sides of the applet?
Yeah.
Everything but.
maybe
Yeah.
we should draw the applet out. So we have the 185 is the mean in the middle, and then the z-score. I'm going to put the z-score in the app and just see what happens. Negative.
What did you guys get for your z-score? Sorry.
Negative 1.920.
Okay, awesome.
Did you guys get for the probability 0.055?
I did.
Sick.
Yep, I did too.
Good.
Yeah.
Sweet.
Who wants to submit?
I got it, guys.
Is that what
Did
you were
put it in
saying?
the applet? Did you put it in the applet, the z-score?
Yeah, and then I highlighted the left and right side and then took the area.
Because it's extreme of both.
Yeah.
So what did you get? I got 0.1. Wait, what was the z-score? I lost it again. It was negative
1.920.
Yeah. Hey, we got 100, guys. Woo!
Good job.
Okay, hang on. Negative 1.9.
And
And so
highlight,
then
highlight you both your left and your right and leave the middle
Blank.
undone.
0.549.
Correct.
And then just round up 0.055.
Not too shabby.
Yeah. Pretty good.
Oh, shoot. I put the answer in 14. Okay, let me fix this. 0.055.
Good job, y'all.
Wait a minute. Let's just, can you carefully review the answer? So 14 was 0.994, right?
Mm-hmm.
And then 13, 0.0051.
Yep.
12, 0.007. And then
Yes.
3.5 on 11, approximately normal.
Hold on. What did you say for 12?
12, I have 0.007.
No. It's 0.078. Just 1 0.
Okay. 9 was 0.0097. Hang on a second. And then 8. Yeah, 0.1480 on 8.
8 was 2.338.
Oh, I'm looking at the wrong 2 points. Okay. And then 7, 1.480 was 7.
0.148.
Shoot. Hey, wait a minute. What was Bruce? I'll call you back in a second, okay? Yes. Okay. Okay. Yeah, thanks. Okay, sorry, guys. I put my answers on a piece of paper, and then I skipped one of the answers. And I wasn't putting them in on the group sheet because I didn't have my, okay. So 9 is 0.0097, right?
Yes.
Okay, sorry about that. Okay, 8. I might have had these backwards, but I had 0.14.
No.
Okay.
8 is 2.338.
I had that down for 9. Good heavens, 2.338. Thank you. Okay, then 7 was
Is
0.148.
0.148.
Yeah. 0. Okay. And then it's 1.045, right?
Mm-hmm.
Okay. And then we decided it was the central limit theorem.
No, the law of large numbers on 5.
Yes, you're right. And the means, the distribution of the sample means, right?
Uh-huh.
Okay. And then it was 0.175, right?
0.175, yep.
Okay. Cool. All right.
You got it?
Yes, thank you. I wrote them down funny this time. Usually I have my my laptop open and another computer open, so I'm figuring out how to work one computer.
Oh, okay. All righty.
So do you guys have a date planned of when you're going to take the exam?
Tuesday.
I will probably take it the last day it is due, and probably as late as I can.
You guys,
So it's due on Wednesday, right?
Yeah, Tuesday to Wednesday is when it opens.
you want to meet our regular time Monday and just like have a brainstorm,
Sure.
or no? That's up to you guys.
I'm fine with that.
Yeah, I'm good with that.
I don't know if I could meet. Well, yeah, I'll try.
You want just
Yeah.
do our regular time on Monday?
I'll
Yeah.
post the link, and then whoever can come, and we'll
Okay.
go over
And
any
then-
questions anybody has.
And then on the Thursday, the 16th, I'm going to be on a flight coming home from Hawaii. So I don't know if we could do it really late Wednesday. I don't know. Maybe you can, maybe you can't. But so I know you have young men. You have young men.
Well, I know, but I can. I mean, if it's like 9:15, if that's okay with everybody.
That's fine
Yeah.
with me.
Fine with me.
So what day are you saying?
16th. So
Wednesday.
it's the 15th.
The 15th is a Sunday.
Oh, wait a minute.
Do you mean the 12th?
I'm just let me look. I'm just
Okay.
my brain is so darn fried with these